Hello and welcome to my channel. In this video we are going to solve some 5-mark questions from Triangles chapter which had appeared in CBSE board exam 2025. Now in this video we are going to solve two questions mainly, that is this first question and this second question. Now rest of the questions, as you can see, that is the first part of the first question, the first part of the second question. Now here in the next page we have the third question and the fourth question. Now all these questions were taken from different sets of CBSE board exam 2025 papers, and all these questions are state and prove basic proportionality theorem or state and prove the converse of basic proportionality theorem. So this question is very important question from Triangles chapter. Now I have explained the basic proportionality theorem in this video, so you can click on this link, or I will also drop down its link in the description box below. So you can refer it first and then understand these questions. Or if you are aware about the basic proportionality theorem, then we can directly start with the second part of the first question. So let us begin with this one now. Prove that a line drawn parallel to one side of a triangle to intersect the other two sides in distinct points divides the other two sides in the same ratio. Hence, in the figure given below, prove that AM over MB is equal to AN over ND, where LM is parallel to CB and LN is parallel to CD. Now here the first statement is the basic proportionality theorem. So you have to prove by using the statement and figure that if a line is drawn parallel to one side of a triangle, then this parallel line is going to divide the rest two sides of the triangle in the same proportion. Now here let us focus on the second part of this question. Here we have to prove that the side AM over MB is equal to AN over ND, and it is given that LM is parallel to CB and LN is parallel to CD. So here let us focus on the first triangle, that is ABC. So consider the triangle ABC. So once we have proved the basic proportionality theorem, we have to focus on the second part, that is the triangle ABC. And from the basic proportionality theorem, since LM is parallel to BC, we can say that this line LM divides the sides AB and AC proportionally. So that gives us AM over MB is equal to AL over LC. And let us consider this as equation 1. Now let us consider the triangle ACD. So consider the triangle ADC, and the line LN is parallel to the line CD. So the line LN is going to divide the sides AC and AD proportionally by using the basic proportionality theorem. So here we get AN over ND is equal to AL over LC. And let us consider this as equation 2. Now here we can see that from equation 1 and equation 2, the right hand side of both the equations are same. So we can equate the left hand sides with each other. So this gives us, so from 1 and 2 we get AM over MB is equal to AN over ND. And this is what we had to prove in the given question, and we have proved it by using the basic proportionality theorem. This is going to be our answer. Now let us move on to the next question. In the adjoining figure, triangle CAB is a right triangle, right angled at A, and AD is perpendicular to BC. Prove that triangle ADB is similar to triangle CDA. Further, if BC is equal to 10 cm and CD is equal to 2 cm, find the length of AD. So let us focus on the first part of this question, where it is given that the triangle CAB is a right angled triangle, right angled at point A, and it is given that AD is perpendicular, that is AD is at 90 degrees to the side BC. We have to prove that the triangle ADB is similar to triangle CDA. So let us begin by considering the triangles ABC and DAC. Now I have considered the given figure over here for easy reference. So here we have broken down the given triangle into two triangles. Now in triangle CAB, it was given that the angle A was right angled triangle. So we have drawn a 90-degree angle at point A, and it was given that AD was perpendicular to the side BC. So in the second triangle which we have drawn, that is DAC, we have taken the point D to be at 90 degrees. So here we have written angle BAC is equal to angle ADC, that is 90-degree angles. And here we can see that in these two triangles, angle C is a common angle, that is angle ACB is equal to angle DCA, that is common angle. And since two angles have become same, we can say that the triangle ABC is similar to triangle DAC by angle-angle similarity criterion. Now remember that when you're writing the similarity, make sure to place the angles properly. That is, since A is 90-degree angle and we have placed it in the first position, make sure to place angle D from the second triangle in the first position because both are 90-degree angles. And then angle B from the first triangle becomes equal to angle A. So we have written them in the second position. And since angle C was a common angle, we have placed both the angles from both the triangles in the third position. So this is very important. Now once we have proved that these two triangles are similar, let us focus on the second set of triangles, which are triangle ABC and triangle DAB. So here again we have broken down this triangle into two triangles. And since angle A was 90 degree and angle D was 90 degree, we have placed them in the same positions. And here we have written that angle BAC will be equal to angle BDA, that is 90 degree angles. And here we can see that in these two triangles, angle B is a common angle. So here we have written angle ABC is equal to angle DBA, that is common angle. And since the two angles have become same, the third angle is also going to be equal. So here we have written that therefore triangle ABC will be similar to triangle DBA, that is by angle-angle similarity criterion. Now here we have equation 1 and here we have equation 2. So here by comparison we can say that since the left hand side terms are same, that is triangle ABC is same, we can equate the right hand side terms. That is, we can write triangle DAC to be similar to triangle DBA. So here we have written from 1 and 2 we get triangle DAC to be similar to triangle DBA, or you can also rearrange these terms and write it as triangle ADB to be similar to triangle CDA. So this is what we had been asked to prove in the first part of this question. And since we have proved this, let us find out the length of AD as it was asked in the question. So here we have taken into consideration the given figure. And here it was given that the length of BC is 10 cm and the length of CD was 2 cm. So we have marked it over here. Now here we have drawn the two triangles which we got as similar, that is triangle ADB and triangle CDA, and we have placed the angle A and angle C in the same position. Angle D was given as 90 degrees, so we have taken it as 90 degrees, and angle B will be similar to angle A. So from the first triangle, angle B, and from the second triangle, angle A is placed in the same position. And here in these two triangles, we can see that we have marked the length of BD as 8 cm because since here the total length of BC was given as 10 cm and the length of CD was given as 2 cm, the length of BD is going to be the total length, that is BC, minus the length of CD, that is 2 cm. So 10 minus 2 gives us 8 centimeters. So that is the length of BD. And in the second triangle, we have marked the given length of CD, that is 2 cm. Now once we have written the lengths and we know that these two triangles are similar, now we can write their corresponding sides to be in the same proportion. So here we have taken the sides to be as, now AD from the first triangle corresponds to the side CD from the second triangle. So here we have taken AD over CD is equal to, now from the first triangle we have considered BD and its corresponding side is going to be AD. So here we have taken BD over AD. Now let us cross multiply this equation, that is AD multiplies with AD giving us AD square is equal to BD times CD. Now here we have the length of BD and we have the length of CD. So here we have written 8 times 2 giving us AD square is equal to 16. Now taking this square on the other side of equal to sign, we get AD is equal to square root of 16 and hence the length of AD becomes 4 cm because square root of 16 is 4. So this is going to be the length of AD, that is 4 cm. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.